Alright, HRW913P081. In a double star system, 2 stars of mass blah 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 each rotate about the system center of mass at a radius of blah blah blah. What is their common angular speed? It's first one. Okay, so I've drawn a picture of this. Oops, that's the wrong button. There it goes. Okay, drawn a picture of this. We got our two masses. They're both a distance r from the center of mass. And what I didn't put is okay, so they're doing this. Okay. So what is their common angular speed? Alrighty. So what I'm going to do is we've got objects traveling in a circle, so I'm going to look at just one of them. Okay, just one of them. Just one of them has a centripetal force pulling it in this circle. That centripetal force needs to be exactly equal to the force of gravity from this over here. If it's not exactly equal, we wouldn't have a perfect circle. So the centripetal force is equal to the gravitational force from the other body. Centripetal force in general is mass of your object times your angular velocity squared times the radius to the center of the circle. Okay, that equals force of gravity to this object would be G m1 m2, same m, so just get mm over the distance between them squared. Well, the distance between them is 2r because it's on the other side of the circle. So I get 2r, all of that. Oops, what happened? Just collapsed on me. Okay, 2r quantity squared. Okie dokie then. If I solve for omega, or rather omega squared, I've got, this is g m squared. Gm squared is already here. On the bottom, we've got 4r squared. Then, to get this stuff off of this side, we divide by m and r. Alrighty. Well, 1m goes away. Just one, though. The r's don't go away. They're all on the bottom. So that gives me gm over 4r cubed. Okay? That's omega squared. So omega is going to be the square root of that stuff. So we got our g is 6.67 times 10 to the negative 11th. Is that right? Yeah, that's right. Just had a little brain fart. M's in the problem somewhere. Mine is 3 times 10 to the 30th. Yours might be different, so be careful. 10 to the 30th. Alrighty. 4r. My r is 3 times 10 to the 11th. Yours might be different. Don't forget to cube it. Alrighty. Put all that in to calculator. And I get 4.30 times 10 to the negative 8, which is what I got over there. 4.30 times 10 to the negative 8. That would be radians per second. Okay. Notice it is common. This is common angular speed because they both have that speed. Okay. Part B. If a meteoroid passes through the system's center of mass perpendicular to their orbital plane, what minimum speed must it have at the center of mass if it is to escape to infinity from the two-star system? Alright, first thing, when I read that, I was like, what? But no, it's actually, this problem's not hard. So, it says that the meteoroid passes through the system's center of mass perpendicular to their orbital plane. That means it's like you're looking, you're kind of looking at this where, like, this is one star, this is another star, and they're orbiting each other, like, flat. You're looking at it edge on. So their center of mass is here, and the meteoroid it's like going phew, like that. Okay, so the reason we have it set up like that is so that as you approach or leave basically the gravitational pull from each star cancels out in the horizontal direction. So we only have to worry about this way, which means we can just focus on the center of mass. We can pretend that these don't exist and instead say, okay, there's a particle of mass 2m right here. So really what we're doing is this problem. We've got a particle of 2m, and we've got this thing when it's at the center of mass, so it's right, let's use right. I've got my meteoroid when it's right here at the center of mass. What velocity does it need to escape from this? Okay, so this is an energy problem. Let's see, I think I can go full screen on this because I've got all my numbers already. Yeah, okay. So this is an energy problem. Remember that the so when the meteoroid is here, it has a certain potential energy and a certain kinetic energy. Let's see that. So that energy is going to be let's see. We've got the potential and the kinetic. When it gets out to infinity, if it escapes with the minimum velocity, then when it gets to infinity, the kinetic energy will also be 0. So in the end, kinetic energy will be 0, and at infinity, potential energy is 0. So in the end, the energy needs to add up to 0. So basically what we're saying is that the magnitude of UG needs to equal the magnitude of K. Alrighty then. So when we're here, UG, we've got potential energy from both of these. So potential energy in general, I'm going to write this up here just so I have more room. Potential energy in general is negative G M1 M2 over R. So we have to add up both of these. So we've got oh, wait, I don't need that anymore. Eep. Oops, too far. No, Charlie. No, just a second. Sorry, my cat is looking for attention by trying to open drawers in the chest of drawers across the room, and he's big enough to do it. This cat is almost 20 pounds, and when he stands up, he can put his feet on the edge of the desk and look at me. I mean, that's like 3.5 feet or something. This is a giant cat. Anyway, I've told you about my giant cat before. Sorry. Okay, so from this one, we've got, let's see, G, big M, little m over R. Because if you're right here, this is R. So is this. Oh, sorry, negative. So then I also have the potential energy from this guy. Okay, and then I've got the kinetic energy. Notice all the m's cancel out. Goodbye. So all I gotta do is solve for V. Let's go. Oh, and I'm gonna have to flip the page. This didn't go well. I should have started B on the next page. Okay, I'm going to move these negatives to the other side so they become positive. So that would give me GM over R just twice. GM over R plus GM over R is going to equal, check again, 1/2 V squared. Okay, 1/2 V squared. Alrighty. Alright, well I got two of these. 2GM over R equals, well, I've got a half of V. I'm going to go ahead and multiply by 2, so actually 2 times that is going to give me V squared. So V basically is the square root of 4GM over R. Plug in those numbers. 4GM, I forgot what M was. M was 10 to the 30th, and R is 3 times 10 to the 11th. Okay, 30th and 11th. 10 to the 30th, 3 times 10 to the 11th. Okay, put all that in, and I get that the velocity should be 5.1, round, 5.17 times 10 to the 4th meters per second, or 1, 2, 3, 4. There we go. When I was putting this calculator, I noticed that I, for some reason, put a -11 on the radius, probably because I had a -11 up there. So that shouldn't be there. That should not be negative. That should be a positive. Sorry about that. Okay, and let's check that. Come on, wakey, wakey. Yep, 5.1700 meters per second. That's it.